So
Yeah,
Luis, thank
hi.
you so much for joining me and my Engineering 5 class.
Mhm.
We teach 7 sections of this course a year,
Okay.
3 in the fall and 3 in the spring, and 1 in the fall and 1 in the spring is online, Zoom this way to accommodate students who are working or there's actually 10 high school students in this class as
Okay,
well.
great.
And then the remainder is college. So I mentioned to the students, Luis, that you're a professor who really is directing the whole movement of getting CSUMB to have a mechatronics program.
Hmm.
So thanks for joining us. We're really in our department really excited that in our backyard we're going to have mechatronics. And
Yes.
for all of you, I mentioned to Luis, I'd like to have him start out by talking about his academic path and then tell us about the program. So Luis, you should have sharing ability and everything.
Yes, so I
I'll
let me
mute my.
share. I'm gonna first talk about just myself in the past, and then I have a presentation about the engineering program. Okay. So it's very nice to be with you. I have been doing this a long time, like coming to high schools or community college to talk about engineering and what an engineer does. So first let me tell you my background. I'm originally from Tampico, Mexico. I was born there, and I did my college there. When I was well, about the school kids age, I was interested. I was good enough in math and science that I got interested in doing something related to science or math. And one of my physics teachers, he was a former engineer. And so he was the one that kind of uh, guide me towards kind of being an engineer. In my city in Tampico, there is oil, and so they extract oil. So there are refineries, and besides extracting oil and process it for gasoline and diesel, there are chemical plants that further process the oil and gas. So they make plastics out of it. So there is a lot of chemical industry around my city. So one of the options for me was being a chemical engineer and get a job in one of these chemical plants. So that was the path I chose because it was a rewarding path. I was good enough in math and science, and I could get a job in one of these companies. Most of the companies, actually, they were foreign companies. They were German companies, American companies, Japanese, Italian. So a lot of the different companies around the world, they have their chemical plants there. So I decided to study that, and then so I studied chemical engineering. It was not my first choice. I wanted to study actually engineering physics. I was more attracted to physics, but in Mexico there is a very bad connotation towards people who do science like mathematics or physics. Like when if you study one of them, they will ask you why you are studying that. If you do you want to be a teacher, so that's like the only option for them to, or the only pathway they can do. And here, if you have physics or math degree, you can do many other things besides teaching. So that's why I wanted to do engineering. So I wanted to do engineering physics, but it was not offered on my city. So and I couldn't afford to go to another city. So I decided to stay in my city and study chemical engineering, it was very good pathway. When I was an engineer, I took all the math courses. Engineering is based on math, physics, and then something else. In case of chemical engineering, it's math, physics, and obviously chemistry. And so took the courses, and it was very rewarding. Sometimes they were hard courses, sometimes they were not that hard. And I did internships, which helped me to find my path towards the career that I wanted. So I did internship in industry, in the chemical plants. I did some internships, and then once I graduated, I took a class. One of the classes that I had to take, it was related to plastics. We call it polymers. And for me, it was very interesting class. Obviously, it was something that attracted me to something from this class. And a lot of the chemical plants in my city, they produce polymers, they produce plastics. So I took that class and then I was like, oh, this is interesting. These materials are like something we make and we can control, and we can control what kind of properties we want from the plastics. So I was very interested, and I started to work in a polymer plant, and it was a very good career for me because I graduated, and when I graduated, they had just finished an expansion of a current plant. So there was a part that was new, a new process, a very big plant. It was 2 million pounds per day of plastic. So it's a mountain of plastic that they produce per day. It was the plastic that we were making. It was the PET, polyethylene terephthalate, is the Coke, the Coke bottle plastics, that kind of plastic. And so I went to there, and since all the process was new, this plant was new. It every day was a learning experience. Nobody knew what was going on. Nobody had experienced some problems that happened, and so for as a young engineer, it was a very good time to learn everything because all the problems were new, and we had to figure out, and we had to try different things to fix them. And when you were trying different things, something else could happen, and then you learn. So you are in this cycle of trying new things, and then something else goes bad, and then try to fix that. And so it was a very, very good learning experience. In that, in a small amount of time that I was there, I was able to acquire a lot of experience. And I saw it because I had friends who also got a job at the same time as me in the other side of the company, which it was next to it, but it was like a known process. They knew what to do. Everybody, if there was a problem, everybody knew what was going on. So they didn't have to, they already knew the kind of the solution. There was no new problems. And I was able to gain very fast, really good experience. So once I was working there, I realized that I wanted to learn more about polymers because they were very interesting materials for me. So I decided to go to grad school, and to earn my master's degree. I was interested in working more like in research and development. So maybe how to discover new properties for a plastic or something like that. So I started to apply to different scholarships and to different schools, and an opportunity came a little bit unexpected. I was emailing people just to find out I was working, I was still working, and I just sent some emails for the following year, because in grad school, you like in college, as you know, you need to apply like way before, like when you want to attend. So I was sending emails probably in May, and I was asking for the following year if there was an opportunity. And one of the graduate advisors answered me, and they say, we have an opening for August, and we can give you a full scholarship if you want to come. And I was like, okay, let's do it. So I had to make a very short time decision to quit my job and leave all my family and everything I know, and just move to Texas. I went to Texas Tech University to do a master's in chemical engineering. So once I arrived there, it was very interesting, but also very challenging. It was now when I was in doing my bachelor's degree, I felt that I was never challenged. Not that I got good grades, since when I wanted, I got good grades. When I didn't want, I didn't study, and my grades were not that good. But I was never really challenged to like something that I couldn't do. I knew if I wanted a good grade, I could get it, and that's it. I just study a little bit more, do all the homeworks, and I do it. And so when I arrived at grad school, it was very hard. It was my classmates were very, very smart. They were smarter than me, and then I had to do all these homeworks that were very hard. I remember one time I was in grad school, and it was a class. It was math, like applied math for engineering. It's called numerical methods. And we tried to solve a problem. There was some homework, and then we go to next class, and the professors asked us, so you finish the homework, and none of us could do it in this particular problem. And he's like, okay, well, I'm not gonna teach until you solve this problem. And he left the room. So he just went outside the room, and we had to solve this problem. So we worked like for only 3 days. Like we were trying to work this problem, and finally we were able to do it. And we had to do it in paper, and we had to program the computer to also solve it. It was like do it by hand and then do it by computer. And so we finally were able to do it, and then we could resume our class. So it was hard, and also it was a time where I had to learn to different cultures. It was a new country. Most of my classmates were from different parts of the world, so it was very interesting for me, and I was very happy to be there. And so I worked again in polymers. My advisor was working in some polymers from that they use in electronic industry. So for me, it was very good and interesting. And then once I finished my master's degree, actually, I didn't have any plan to when I finished my master's degree. Uh, I I assumed that I was gonna get my master's degree, maybe work a little bit in industry, and then my plan was go back to Mexico. I wanted to go back, but I met my wife while I was at grad school, so I met her my first year, and she was doing a PhD, which is a PhD is a very long time, is 4 to 6 years usually when you do a PhD. So then I finished my master, and I didn't have any plan. My then girlfriend was there, so I wanted to stay. So I found a job in a research center. It's called the Fiber and Biopolymer Research Institute, and this center, um, basically what they do is they study cotton. They study cellulose. Cotton is very common crop around Lubbock, Texas, where Texas Tech is, and they study different aspects of cotton. Cotton is a natural plastic. It's pure cellulose. It's the purest form of cellulose found in nature, and I worked in projects related to maybe how to make cotton antibacterial, so it can kill bacteria, how to make cotton water repellent, so it repels water, liquids. But I also worked in the crop science part of the cotton, which was very interesting. It was things that I didn't work on before. So usually for polymers, you have your chemicals, you have your reactor, you have the temperature, so you kind of control everything. With cotton, you don't control too many things because it's nature, right? So there is weather, there is rain, there is soil, there is all these many factors that if you want to study it, you need to learn other skills. For example, you need to learn very well statistics to do this kind of study. So I had to learn other things besides just engineering and material science. I had to be very good at the statistics. I had to learn a little bit about soil science and plant science and other things. So I worked in a team. They were trying to put some chemicals inside the cotton fiber. So the cotton, they harvest it and then they put some chemicals sometimes to make the dyes to attach better to the cotton. So what they wanted to do is to put this chemical, grow the cotton with this chemical, basically already in the fiber. So that is a little bit. It may sound easy, but it's a little bit challenging. You have to work with chemists. You have to work with people in biotech that do genetic modification. So it was a whole group of people, and it was very interesting project because it was something very different that what I have done before. So I was there. I spent my years there, and while I was working full time, I got my PhD in Texas Tech again. So once I was there, I was still very interested in working like in research and development, and maybe working in a chemical company and developing plastics and things like that. That was still my interest, and little by little, I started to realize that my past background, when I look backwards, I was always kind of engaged in some sort of teaching. So, for example, in my high school, I went to like a Catholic school, and we had to do every year, like we have to do community service. All the years that I had to do this community service, all of them were related to teachings. I never saw myself as a teacher. My mother was a teacher, elementary school teacher, but I never saw myself as a teacher. And then I realized that I really like to teach. I was teaching other students how to, some things in the laboratory and things like that. And I realized that I really like teaching. I really like to do all this teaching. And then I realized also that if I'm a professor, I could do research and I could do teaching. I could do kind of both things that what I wanted. And one of the things that struck me a little bit more was when a chemist, he taught me many things. He was working in this same center and he retired. And he had been there, I don't know, like 40 years or something like that. He had been there for a long time. And he retired. And when probably a week after he left, all his laboratory was taken down and we put new equipment. And it was a little bit, I didn't expect that, nobody is gonna like conserve my lab, like, like in a museum or anything like that. But it kind of struck me like, what's gonna be my legacy after I retire in 40, 50 years, once I retire, what's gonna be my legacy? And then I thought, and one of the best legacies I think is that to pass things to our students. And I kind of like think like I live through my students, even though they get jobs and they get professional license. I don't do anything, but I think I get some sort of credit. So so that's one of the main reasons why I went to teaching. And so I decided to go to as a professor. I could do some research project that I'm interested in, and I could teach. And also for research wise, if you are working as a professor, I could do any topic that I want. I could do polymers. I could do, for example, I was always interested in working in water, like cleaning water, and I never had the opportunity to do so. So when I got my next job, I was able to work also in cleaning waters. So once I finished my PhD, I got hired at CSU Bakersfield to and so I worked there. I was hired as a professor, and I got to start the engineering program. We started an engineering program there. It's very close to a mechanical engineering degree. We just call it engineering, but it's basically a mechanical engineering degree. And it was very successful. We started with 6 students. We went all the way to three. The highest number at some point was 300 students. We developed emphasis for the local industry. It was petroleum engineering, agricultural engineering, energy, power and energy, and engineering management. So our students got jobs. They went to graduate school. They did master's programs. They did PhD programs in very good universities. So very successful program. I had the students working with me. We were doing different projects, and they got internships. So we published some papers, scientific papers with me. We went to national conference to present the results of our publications. We worked, for example, in projects related to make plastics from renewable sources. Right now, I still have a student there in the lab in Bakersfield. I'm finishing some projects. He's working with pistachio shell powder, mixing it with plastics, and we have a lot of pistachio shells in the Central Valley, a bunch, mountains of pistachio shells waste. And also, I started working with how to clean the water from oil field to use it for irrigation. In Bakersfield, for every barrel of oil, and we produce a lot of oil in California. Actually, it's the fourth or fifth state production state in the country, so that's a lot of oil, and most of it comes from the area around Bakersfield. And for every barrel of oil that they produce, they extract 7 barrels of water. So basically, they are water producers that they sell all on the sides, but so it's a lot of water, and they need to do something with that water. So they use some part right now for irrigation, and I work in different projects how to maybe clean it better. And also, one of the interesting projects I worked on was what happens once you irrigate the soil, what happened to the soils and what happened to the plants, if it's good for the plant or for the soil or for human consumption. And you may think that this had been done before we irrigate this plant with this water, but it was not, surprisingly. And so we worked with different people from different universities to study this problem. So it was very interesting time. And then suddenly I had the opportunity to come here to CSUMB. I was assistant professor, then associate professor, full professor. I was the chair of the physics and engineering department. And I was suddenly given the opportunity to come here to CSUMB to start a mechatronics engineering program. So start from scratch, a new program. I did that in Bakersfield, as I mentioned. I was a professor. There were other people doing a lot of the administrative work behind what it takes to make a degree. So, but now I had the opportunity to come here and do a lot of the administrative work myself and creating this department from scratch. That's I came. It was a good challenge to start new things. I always liked that, as I mentioned before. Several times in my career, I had to do new things and new challenges. So this was one more. And I came here in last August, and I have been working towards getting this program up and running. There was obviously a lot of things done before I came here. Like there was a lot of paperwork. It takes a long time to create a program, but now I'm the only person in my department. I'm the chair of the department, and I have been hiring. I had interviews yesterday. I had interviews today for a staff position. So I have interviews tomorrow for another faculty position. So we are gonna be ready in fall to start this mechatronics engineering program. So let me share. So this is a little bit about my life and how I end up here. If you have any question about the program, please feel free to email me. Here is my email. You can reach out to me. So just an announcement, if you are maybe engineering, you decide not to do engineering because you feel it's not good for you, something happens, you thought it was good, but now you don't like it. Well, we offer other STEM degrees that are very good. We offer all these STEM degrees, but we also are going to be offering mechatronics engineering. So let me start with mechatronics engineering. So basically, mechatronics engineering is the mix of mechanical engineering, electronics, computer, and control systems. It's not very common in the United States, but it's very common abroad. If you go to Mexico to university, if you go to Middle East, Asia, they have mechatronics engineering, master's degree in mechatronics, PhD mechatronics engineering, things like that. Uh, our program is the courses. If you see the courses, half of them are mechanical engineering, half of them you will find them in electrical engineering programs. We are starting this fall. We are going to accept freshmen, and we are going to accept transfer from community college. We are going to work towards ABET accreditation, which is important for engineering. We have first a student has to pass through the curriculum before we can apply for accreditation. So that's common for all the engineering programs, and we are working with industry. We are talking with them to find opportunities for internships and jobs for our students. I think this is a great location for that program. We have great agricultural technology in Salinas. Is one of the capitals for ag technology. There is a lot of things going on in Salinas about ag technology. We have now aviation industry. Jova, is from Santa Cruz, but a lot of their operations are here next to us in Marina, next to CSUMB. We have workplace institutions, world-class institutions that do marine robotics. For decades, they have been leaders in marine robotics. So we also have educational institutions. For example, we have the Naval Postgraduate School. I talked with them. They're very interested in having our students doing internships there. So we are going to have new remodel laboratories. We are remodeling right now. We have 2 laboratories for now, and there is now we are soon going to have news about a new building. Okay, so we are going to have news about a new building. We are going to build something new for not only for engineering, for other programs. Our programs is very hands-on. We have a lot of courses with labs. All these courses have a laboratory component, so it's very, very hands-on, so where the students can learn a lot about the engineering. This is roughly our labs. We have the mechatronic labs that they are going to remodel now, and then we will have the materials/signal labs. We are, as I said, I'm hiring 2 faculty that are going to come, 2 professors that are going to come this fall, and we are going to have also hiring staff. Mechatronics engineering, you have a lot of math, physics, calculus. You have a lot of the courses in mechanical branch with material science, strength of materials, statics, dynamics. Then you have your junior year, as a transfer from community college, you will come here. So your first semester, like third year semester, will be dynamics, will be signal, digital context designs, and then at the end of the end of the year, at the end of your career, you will have the senior design. This is typical for all engineering programs. You do 1 year design, and you work in teams to design something. It could be a drone, it could be a scientific instrument, it could be certain prototype. So in theory, you apply all the knowledge from your courses into a single project. You work in teams and you are under the guidance of faculty. Sometimes we may work with industry. We hope to provide some research opportunities for the students. That's what we did in Bakersfield. And these are students of mine presenting the research in different places. Some of the students can publish with us. We are working with industry to get internships and to visits and invited speakers. And so our program, there will be different areas that we are going to cover. Some of them will be in agricultural technology. I do water, for example, and materials. This is the areas that our program will cover. Examples for careers, you can work anywhere where there is some automation. You will have a career. It could be a project engineer, control engineer, or robotics engineer. The important part is that you are an engineer and you are going to be very versatile. Once you have an engineering in your degree, I have students who have changed careers. They have been in ag industry, they have been in oil industry, they have been in construction industry, and they switch back and forth because they have an engineering degree. So let me see, let me go to the questions. There were some questions from the side. So if I have a favorite area to work, I have worked in different industries in materials, petroleum, education, and now mechatronics. If I have a favorite, they're related. One of my favorite areas, obviously, I'm from a materials engineering background. That's one of my still favorite areas. But materials engineering, the nice thing about it is that it's related. So one of the ways how I started with water is because the membranes to filter water, reverse osmosis membranes, are made of polymers. And that's my expertise. So I can work in membranes to filter water, to make better membranes to filter water. So materials is related to many things as well. So in mechatronics, for example, I can develop new instruments to test certain properties in the materials. That's one of my goals that I want to do. And coding, let me go back a little bit. They are asking me if they are coding classes. Yes, there is coding classes sorry, I went a little bit fast over the curriculum. You have to take 2 courses in computer science department, problem solving. This is right now they are using Java, and then intro to data structure. These 2 courses are in the computer science department. And besides that, there may be a little bit other coding. We use MATLAB for some of the classes, for example, signals in junior year. In this class, you will use MATLAB. There are some classes, these and other classes, you will use MATLAB. So signals, you will start using also MATLAB for that one. For agricultural technology, since the program is new and we still don't have students, I have been talking with many companies. The question was if we have any projects lined up for students in agricultural technology. I have been talking with different companies from small to very large, and they are very interested to have our students doing internships, and probably we are going to start working in some of their projects. I know, for example, there is in Watsonville, there is a company called Farm NG. They have what they sell is like a robot, like a very easy to program robot. And one of the opportunities there is that we can buy one of these small platform for robotic platform, and we can make an accessory, like for example, a weed killer, a laser weed killer. They already have that, but it's just an example. We can do different accessories for this robot in particular, and that will be one of the things that the students could do for their senior design project. Do you have any other questions? Let me see. Oh, accreditation. This is a very important question. So as I say, we cannot apply for accreditation until a student has gone through the curriculum. That's one of the things that's how ABET works. It works for us and everybody else. We hopefully we get a transfer students this fall 24, and that transfer students, at least one, will graduate in spring 2026, right? In spring 26. And in spring 26 is that when is hopefully, there are a lot of factors. There are many different moving parts on this, okay? We have to submit a document for in that summer of spring 20, after spring 26, we need to submit a document. Before that, we need to apply and send like a pre-document. And this document is a 300-page document, okay? So it's a lot of things and that we need to get right. We need to get faculty, we need to get labs. So if we do everything right, by after in summer 26, we submit this big document. They visit us in fall 26, and then we get one, like a few months later, we will learn if we get accreditation, and it should be retroactive to people graduating in spring 26 if everything goes right. I cannot promise that we will get accreditation the first time we apply. We may not get it. In Bakersfield, we got the first time we applied, and last year we went again through accreditation, and we got you apply every 6 years, and we got again full 6-year accreditation. So I have done this already 2 times. And it's a very it's a long process, and it takes a lot of effort to do this, but I cannot guarantee for sure that we will be accredited when you graduate. I cannot say that. The other thing for accreditation is that it's important, but if you graduate, let's say we don't get accreditation, you graduate with our program, you still can get a job. Most of the companies, they will ask about accreditation, but they hire our students in Bakersfield. We didn't have accreditation, I think, the first 2 years. They graduated and they got jobs. All of them got jobs. They got internship. They got hired. They are now managers. They are doing different things without accreditation. A lot of, especially here in California, a lot of engineers work here that they went to school abroad, right? Like my school from Mexico, they are not, this is not accredited from AVID, but I still could get a job here as an engineer in the United States. So a lot of international people, they get jobs still.
Thank you, Luis.
Okay.
I enjoyed hearing your background, and then what you're doing. And I'm sure you're going to get ABET accreditation. You've been through the cycle twice. And those of you in class who don't know what ABET accreditation, we're going to talk about that next week, because next week is when we're talking about professionalism and things. So,
Yes.
are there other questions for Luis? Would you put your slide up there with your contact information, the first one? And engineering five students are typically new students, so they're a few years away from transferring anyway. Although you do have, like I said, 10 of the 30 students are high school students. So what other questions?
For students, for anybody who is transferring in 2 years, we're gonna be super ready for you. Like we are ready, but like we will have everything to show. We can give you a tour before you come. So right now we are building the labs, we are getting equipment, so there is still a lot of things that we are working on.
Yeah. Okay.
Hey, can I ask, why did you guys choose mechatronics engineering?
Well,
as the first, because you don't have other engineering classes.
Yes, this is the first engineering program here. I think it's going to be a very successful program. There is the right combination because of the industry. There is some industry that there is a lot of automation in ag technology. There is marine robotics also. There is a lot of things in marine robotics. So I think this was the right program. There is only 3 mechatronics engineering program in the CSU system. One is in Chico State, and the other one is in Channel Island, which is relatively new, is 4 or 5 years old, and then us. they are asking if is there a transfer agreement for the
Yeah.
mechatronics program?
Yeah, there will be for on assist.org, yes.
Yes, there will be, and if there is, not is our courses, the 2 first years are very exactly almost as the community college courses, because we will base our courses on a common course, so it should be very easy to transfer. Even with community college that we may not have an agreement, it should be very easy to transfer.
Yeah.
And then the
In
other
fact,
question.
our department was working with CSUMB for a few years now in developing their
Mhm.
coursework.
Yes.
Tomas, did you have a question?
No.
Oh, okay. Someone else want to have a question? No? Okay, Luis. It's the end of our class anyway, so
Yes.
I think we'll maybe sign off, and thanks again for
Mhm.
coming and speaking to our students. And I'll probably post your little video on the engineering department website as well
Sure.
in the next
Good.
few weeks.
Yes,
And then
that's
I'll be
okay.
in touch with you about future students and coming on tours.
Okay. Yes, absolutely. Thank you very much for having me, and have a good day. If you have any question about our program or engineering in general, feel free to send me an email. Okay.
Okay, sounds great.
Mhm.
All right,
Bye.
thank you, Luis.
You're welcome.